So today we will start about finite state machine. So the finite state machine, one of the type is your finite automata. So you have two types of finite automata to go with. So one is your finite automata with output, and another one is your finite automata without output. So you have two categories. So you have one more subcategories to go with. So one is your Moore machine, another one is your melee machine, and same in case of your finite automata without output. So you have three classifications. So one is your DFA, another one is your NFA, and next one is your epsilon NFA. So this is what. So your finite automata will be divided into two categories. One is finite automata with output and finite automata without output. So this finite automata with output, you have two classification. One is Moore machine and melee machine, and finite automata without output, you have three classification. One is DFA, NFA and epsilon NFA. So first we will be learning about deterministic finite automata. So here you have what is meant by deterministic finite automata is, so based on the structure, it is simplest model of computation, and it has very little memory. So these are the two main characteristics of DFA. So let me explain very simple with the diagram. So DFA diagram, say for example I am just considering four states A, B, C and D. So when it case to for the input value, so this is the diagram for DFA, I am just doing it. So let me take, it has an input values of 0 and 1. So make sure all inputs are mapped to all inputs. So when I am just taking A as an initial state, so I have a transition from A to B with an input 0, and A to C with an input 0, and again C to A and with an input 0, D to C with an input 1, and C to D with an input 1, and B to D with an input 0, and D to B with an input 0, and from B to A with an input 1. So when you just look into the diagram, you can just check it. I have two inputs 0 and 1. So when you just take the first state, you have both the inputs are mapped. So 0 is also mapped, 1 is also mapped. The same way when you take B, 0 is also mapped and 1 is also mapped. When you take C, 0 is also mapped, 1 is also mapped. When you just take D state, 0 is also mapped and 1 is also mapped. So after this we can just see what are the tuples you have it in the DFA. So when you just take out DFA, you have 5 tuples to learn with. So there are 5 tuples. So what are those tuples is Q, epsilon, Q naught, F and sigma value. Okay, so what is mean by Q is, so Q is nothing but set of all states, and epsilon is your input function, and Q naught is your start state or initial state, and F is your final, and F is your final state, and this transition is, this is your transition function. So in case of your DFA, it can be represented as Q into epsilon value will give you the q value. So these are the 5 tuples we just wanted to learn. So for the same diagram, when you just write the transition table. So when you just write the transition table, so you have how many states you have? You have totally 4 states to go with, and you have totally 2 input values. So A when 0, where it goes to C, and A11 when it goes to B value. The same way you have to do it for all values. So B when 0 it goes to D, B when 1 it goes to A, again C when 0 it goes to A, and C when 1 it goes to D, and again D when 0 it goes to B, and D when 1 it goes to C. So this is the transition table. So in DFA you have 5 tuples to go with, that is Q, epsilon value, Q0, F, and this transition functions, and this is your transition table.